Hello everyone, I'm going to talk to you about how to do clean architecture orchestration with Apache Camel, which is an integration framework. First, I want to introduce myself a bit. I have been on this software industry for more than 15 years already. And well, in 2019, I entered Red Hat, in which I specialized and focused on the integration framework, service components, composition, orchestration, and specifically with Apache Camel, which is a software I will introduce later. I'm also a Java champion, and I am a very strong free and open source advocator because I seriously think this is the only way we can create software that have the appropriate quality we need. I want to start with a bit of a historical ride over software architectures. Probably all of you know that when we started the software industry, especially this was very common on the 60s, 70s, the monolithic architecture. What was the monolithic architecture? Well, everything was on the same source code, the same base source code. It was not modularized. It was everything on the same place. The concept of dependency was even weird at the beginning. Then later, some libraries were introduced. But in the beginning, monoliths, well, they were easy to develop because there were not many strong dependencies involved. You didn't have to interact with other services, APIs that maybe someone in a team nearby was developing. Everything was connected to everything, generating high coupling. If you needed to modify one small piece of code somewhere, it usually affects a lot of other pieces of code somewhere because all the model was shared, everything was intermixed. Also, any minor change in the software meant that you have to rebuild and redeploy the full monolith because it was one piece of software. And obviously, scaling that monolith was difficult because you couldn't say, I'm going to scale this part that interacts with the database, or I'm going to scale this part that interacts with the front end. As it was a monolith, you had to scale everything. So it was easy, it was nice, it was even fun, but it was kind of difficult to handle big projects or ambitious projects with it. Then we evolved to multi-layered architectures. The multi-layer architectures, well, this is the most common example, the model view controller architecture. It has a concept that runs very close to the implementation. So you have three different pieces of software that were very interconnected, but you could improve one of them without having to redeploy the other ones, as long as the contract between the components was stable, didn't change. And the idea was to separate concerns. So on one hand, you have a piece that connects to the database, to the storage of data, whatever it is. Another one converts that model into something that is a user interface or something that the user can manipulate. And then there was the controller that modified these pieces of data. The model modifies it, transforms it, and do the work that the software is supposed to do. So it was each layer acted more or less independently. So the scaling and the testing became easier. You could, as I said, you could modify something internally to any of those components. And well, as long as the points of interaction with the other components were satisfied, you could deploy and modify the specific component without having to redeploy everything. But then the more stable and decoupled these layers became, the more this type of architecture evolved to what we know now as a microservices architecture. So here, which is more or less what all modern software follows, more or less, each service has a contract to interact with the other services. It could be an endpoint, REST API, messaging queue. It could be different types of how they interact, but they interact with each other. And as long as that contract between the components is maintained, you can replace each of those services with anything that maintains the contract and follows the contract. The good thing about this is you could even remove pieces of these services as long as you don't need them in other services, and replace them to something that is written in a different language, something that is written that is doing something completely different, as long as this contract works. So this made it everything easier to escalate. If you needed to escalate the front end, you could do it without having to escalate the database. If you needed to, maybe some of these services have long-run processes that required a lot of CPU or memory, you could even deploy them in different services, that as long as the contracts between services were maintained, that's fine. The microservices architecture has led to something that I have been using only in the last few years, which is the micro frontend architecture, which is taking the same idea of the microservices but to the front end. Instead of having one monolithic front end, which is more or less common nowadays, you have the micro front end. So even the front end is composed of these micro things. This obviously requires that the front end has these contracts. This requires that all the different pieces can work together, but that's fine. And this is how, well, the state of the art of how you should implement services and how you should implement software nowadays. Of course, this depends on the specific use case, it depends on many things, but more or less everybody agrees that this is the most adequate model if you want to, in the future, escalate or be able to refactor or be able to whatever. So all this microservices architecture has allowed for a much faster and reliable development, because also independent teams can work on these services and they don't need, as long as they agree on this contract. I'm very focused on the contracts, and you will understand then later why. As long as you agree on the formats, the protocols, the how you're going to interact with each other, you can have even each service developed by independent companies, and that's fine. You could even call third-party services and make them part of your architecture with a more or less reliable, being able to offer a more or less reliable service. This also means that this also led to what we now call the hybrid cloud, in which you have services scattered around different cloud services. You can have something in Amazon and something in Google Cloud and something in IBM Cloud and something in local OpenShift, whatever, and they all interact with each other and they are all happy. But this type of microservice, you have to agree with me, this also introduces a complexity to the service orchestration, because now, instead of one monolith that you monitor its app and that's it, you have a lot of services. Each of them has their own requirements on how you have to talk to them. Some of them use YAML, some of them use JSON, some of them use whatever, CSV, even XML. There are services that still use SOAP. How do you make different services interact with each other if they don't speak the same language or they don't speak the same protocols and data formats? Well, usually you use what we call middleware, and this is what I'm going to talk to you about on the following session. How can we compose these services? Well, it's like a puzzle, and it's not as easy as on this photo where all the pieces fit together, because as I said, maybe you are talking to database and it's returning a model that does not fit the model of the API that you need to call later with that data. You need to do some ETL, you need to do some transformation of that data. Maybe it's just renaming columns, maybe it's something a bit more complex, but you need to change it to be able to call the following service. Or maybe you are interacting with one service in HTTPS and the following service is a Kafka message queue. How do you get the HTTP content and send it to the Kafka queue? Well, with middleware. Every time we add a new component to our architecture, we need this piece of software in between to translate the data and integrate the protocols with the rest of the components. If we're not careful generating this middleware, we will be generating dependencies and coupling among different services. For example, this example of an HTTP connecting to a Kafka service. Well, you can use your language of preference, Java, Python, Bash script even, and call this HTTP service, transform, tweak a bit the data with quick script, and then push it to a Kafka broker, and that's fine, right? But then if in the future we need to replace one of those services or the interacting interface changes or we introduce a new service to the composition, we may find we have to rewrite these pieces of code again and again, maybe instead of HTTP, or maybe we move from HTTP to HTTPS and now we have to handle certificates, or maybe for whatever reason now it's not an HTTP service, now it's an FTP. Well, it's not a big change, but now you have to change it. And now you have to test it. And now it's tiring, boring, and it's adding an overload to your normal development time that doesn't need to be there. Because fortunately for us, this is exactly what integration frameworks do. Integration frameworks allow us to compose different pieces of software with minimal development. Of course, there's a minimal development. You have to explain how to do the ETL. You have to explain what is the protocol you're using, but it's very minimal, and then it generates a lot of coupling because the integration framework is prepared to change the entry points or the output points of this middleware, this tube, this pipeline. Is prepared to change it without having to rewrite any piece of code. There are many integration frameworks or libraries. To choose the right one for your use case is not as easy as it sounds. I'm going to explain to you the criteria I like to follow for choosing a good integration framework. And there are many options, but it's true that not all the options have all the criteria I'm going to tell you. For example, obviously, the most important thing is the functionality. You need to have a wide range of support formats and protocols. Why do I say this? Because imagine you find a nice integration library or integration framework, and it supports JSON, it supports XML, it supports, and then, I don't know why, you get some weird data that has a very obscure format. If your integration framework does not support that format, well, either you have to write your own piece of code that translates and transforms this data format to something your integration framework understands, or you will not be able to interact with this integration framework. So yes, having a wide range of supported formats and protocols, that's important, and it's more important than it looks like at the beginning. At the beginning, you may search all the features and specifications of the integration framework and say, well, everything that I need right now, it's supported. But what happens in the future? There are still many services that use SOAP. If you don't have an integration framework that supports SOAP, you may run into issues later. Of course, this depends on the use case. If you are pretty sure you're going to work only with JSON or only with XML or whatever, and you're not going to change ever, then that's fine. Then it's important that it has extensibility. Why? Because in the rare case that whatever you need is not supported already for your enterprise for your integration framework, then you need to be able to add a plugin, extension, module, call it whatever you want, but you should be able to add this type of protocol or data format so your integration framework understands it and is able to interact with it. If you're not able to extend the integration framework, you may find that maybe you have issues in the future. For example, getting a file from an Amazon S3 bucket or pushing something to the Google Cloud data storage. This is it has a very well-defined API, but if your integration framework does not support it, you will have to call manually that API. And what if that API changes? They change. Usually minor changes, but they change. Then you are the one that have to maintain that API. This is not what we are looking for an integration framework. I want to be able to tell the integration framework, hey, I want to get that file from this S3. I want to get that SQL from this database. I want to get this data from this NoSQL database, and I want to conflate everything here and push it to a RabbitMQ. And I want to be able to say that without having to implement how the RabbitMQ works, how the S3 gives me the file, how the database or the NoSQL database get the data and how to conflate it. I want to be able to define all this without having to get into the details of the implementation, because implementation changes. And if the implementation changes and you are the one responsible of the piece of code that does this transformation, that does this interaction with the remote service, you are the one that have to maintain and re-implement that piece of code. So the more we can delegate into the integration framework, the less work we have to do. And this leads us to the enterprise integration patterns, which I'll just skip, even if it was the most important thing, and that's why it was at the top. The enterprise integration patterns, I will show you later examples of them, but they are like the software patterns, software design patterns. They are common patterns that happen when you need to integrate or compose services, for example. Simple things like I want to, depending on the response of a remote service, I want to call service A, service B, or service C. This kind of if, which can be also a loop. I'm going to get a lot of rows from a database and I want to loop over these rows, and for each row I want to do something. I want to be able to tell the integration framework to do this without having to write an if or having to write a loop, which is not that simple. And then there are more complex enterprise integration patterns, like reorder this list of messages for me. And this is the criteria to reorder, but the messages are coming unordered and I want to reorder them so I can push it to the following API with all of them ordered. So functionality is obviously a very important criteria on when to how to choose an integration framework, but it's not the only one. Usability is also interesting, of course. Good documentation and tutorials. If your integration framework has a lot of features, a lot of functionality, but you don't know how to use them, or you don't even know it exists, what's the use? No, please, I need to know what I can do and how to do it to be able to properly use it. So good documentation and tutorials, that's a must. Having multiple DSL. What's a DSL? A DSL is a domain-specific language. This means that it's a specific, when you describe the integration framework, what you want to do, what services you want to compose, what you want to how you want to interact with each service, what kind of transformations. Some people come from Python, some people come from R, some people come from JavaScript, some people come from Java, some people are comfortable with XML, some people are comfortable with JSON. Which language I'm going to use to explain to the integration framework what it needs to do to define this orchestration of services, this workflow I'm trying to define. Well, usually the integration frameworks have their own language, which is what is called the domain-specific language. If the language is hard to learn or is not very familiar, it's going to be ugly to use it. You can learn it, but it's going to be ugly to use it. So if usually these languages are based on real languages. Some of them use Java, some of them use JavaScript, some of them use XML, JSON, YAML. If your integration framework allows you to use multiple DSL, for example, I can define this integration in Java or JavaScript, and I know it's going to do the same. Or I can define this in YAML or in Groovy, and I know it's going to do the same. That's an advantage, because then I'm not restricted on who can maintain this integration, this workflow. I can tell my Groovy developer, I can tell my YAML expert, I can tell my Java champion to just do it and maintain it. So having multiple DSLs is not a must, but it's a should. You should have. It simplifies your maintenance later. Maybe your Groovy expert did a lot of things and then they left the company. Who is going to maintain that? Well, you can translate that to YAML maybe, to Java, and use your Java developer. If you have multiple DSLs, it gives flexibility. And of course, the footprint, the CPU and memory footprint, it's important that your integration framework is not so heavy that it makes your architecture slow and expensive. So having a low footprint with all the previous things we have mentioned, it's important. And the license. The license, sometimes we skip the license. We get some commercial salesperson tells us, oh, this is your solution. And it's true, it has all the previous things. But you know what? If the integration framework you choose is not free and open source software, it's not FOSS, it does not have a free, as in freedom, it may cost money, of course. If it does not have if it doesn't give you freedom to modify it, to run it, it has a disadvantage. Because if you use FOSS, you can hire anyone as technical support. If you don't like the company that is giving you technical support, if you don't like the company that is developing these integration frameworks for you or these extensions for you, just change to another one. But if you're tied to the whims of a private company that is the only owner of that source code of the integration framework, if you don't like how that company answers you, or if you think they are too expensive, or if you don't like the type of technical support they give you, you are tied to them. And as your architecture has been built with this integration framework, all your architecture, you are creating there a dependency that doesn't need to be there. So it's important to choose and read the license properly and make sure you are not going to be tied to a specific company that today can give you a good service for a nice price, but tomorrow can say, well, I'm going to raise prices by 10 and you are tied to me. So what can you do? And of course, I work in Apache Camel, so this is the framework I'm going to recommend you. It's FOSS, but it has many companies behind it, among others Red Hat, which is the one I work for. So you have a wide range of options of companies to hire for training, develop extensions, fix some bugs, fix some, add some features. And it has all the previous criteria. It has 360 something different protocols and data formats, which is a lot. And it's extensible. It's FOSS. If you don't like how it works, if it doesn't have exactly what you need, you can hire someone or implement it yourself and just add it to the project. So most of the potential use cases you will ever need are already covered, if not all. If you have some very weird specific use case, it's easy to extend. And it has a very low memory footprint. It has a very low CPU footprint, especially if you move to in the cloud version, the camel-k. It's you don't. It doesn't for every deployment you do of this of an integration, it doesn't add all the dependencies of the 350 something components. It cherry picks the dependencies it needs. So the footprint, the memory footprint is very low. Also, it uses Java Quarkus, which is fast and it's amazing. Java Quarkus, if you don't know Java Quarkus, you should check about it, because Java is no longer big. It's fast as a bash script. It just runs. So what does exactly Camel and any other integration framework do? Well, you have the different components, A, B, C, and then it has a connector that knows how to speak A, a connector that knows how to speak B, a connector that knows how to speak C, and then it has the different links between components. So the connector A talks to the connector that B and pass the information from one to another. This is a list of the enterprise integration patterns that Camel supports. They are most of them. If you're interested in enterprise integration patterns, there is a very good book called Enterprise Integration Patterns that explains in detail all of them. But as I mentioned, you can have the message router, the if depending on the previous step, I want to send to different service components. You also have, for example, the multicast. It's not that I want to send to A or B, I want to send to A and B, or the loop, the message filter. If the message, the data that is going through this pipeline does not have certain criteria, just don't stop here and don't continue sending anything. You have the reordering of messages, as I said before. The aggregator, I have maybe 10 incoming messages. I have been looping over a lot of rows of a database, and I have resolved for each of those rows of the database. And now I want to conflate all of them into a single message. So instead of calling 5 different APIs, I call one of them with the information of all those 5 messages. So there's a lot of enterprise integration patterns. They are already implemented inside Camel, which means you just have to say, hey, use these enterprise integration patterns. And these are the parameters, these are the criteria to do it. Which allows, as I say, to do things like this, something more complex, something more, I want to be able to, from A go to B and D, and from B go to C, but D doesn't end here. So it has different threads, it has different paths in the same workflow. And in the end, an integration is a workflow defined. It's you are just explaining how I'm going to gather or get data from A, and I'm going to send it to B and D, maybe with some transformation in the middle to maybe A is exposing an XML endpoint and B understands JSON. Well, I want to automatically transform that XML to JSON, and I want to be able to do it maybe tweaking the names of the attributes, maybe removing attributes, maybe adding new attributes, I want to do complex stuff. And this is a bit of the bowels of Camel, what it does. The external systems are the A and B. It can be, I don't know, S3 bucket, which I already mentioned. It can be a database. It can be a normal API. It can be anything. External services. The consumer and the producer are the parts of Camel that speak the same protocol and language that the external systems speak. The exchange is the message that goes through Camel, and the router is the one that decides if it's going to go to A, to B, to C, or to all of them at the same time. And the router has also the data mapping, the type converter. So if one speaks XML and the other speaks JSON, I'm going to convert it. If one and if I need to remove or add new attributes, I can do it, etc. So Apache Camel has a domain-specific language to define the relationships and workflows that run between components, as we have seen. And this DSL simplifies the details of the middleware implementation, as I already explained. But let's go with an example which will be easier to explain. So imagine we need to implement this workflow. We get a data CSV file. We want to iterate for each of the rows of this data CSV. We are going to split the thread of this workflow into one thread per data row. We are going to process these rows independently, calling some XML API to gather some data based on one of the values of this CSV. And the result data will go through another process in which we are going to call a database to enrich the data inside this that was the rows plus the XML API result. And then we are going to aggregate all those different threads into one single data, and we are going to store it in our database. So if you think about this, if you need to implement this manually, how many lines of code or even how many files do you need for this? You're probably thinking, well, I need to have one. If you are in an object-oriented space, I need to implement one class to grab the data CSV and read it and split it. Then probably I will need another class for the XML API calling and conflating the data with the rows. Then probably another class or component that interacts to the database through this SQL. Maybe another class to aggregate everything into one single JSON. In this case, it's going to be a GeoJSON, but it can be anything. And then finally, another class or function, if I'm bold, to store into a database. But if we do this with Camel, the code is this one. It's 28 lines of code, and more than half of them are comments. So this is the implementation of this workflow into Apache Camel. I started with a timer because you always have to start with a step that triggers something. It can be a database trigger, it can be message queue receiving a message. In this case, I simplify and say, well, what I'm going to do is every 10 seconds, I'm going to grab this source CSV. So the line number 2 says every 10 seconds, I'm going to run the following. Line 4 says, get this source CSV. It can be an FTP, HTTP, whatever, depending on what the source CSV variable, how the source CSV variable is defined, it will grab this from an S3 bucket, FTP, HTTP, whatever. And the interesting thing is, if I change where that CSV file is, I just need to change this line 4. I don't need to modify anything else. Then I know it's a CSV file, so I unmarshal and split, which is the way of telling Camel, this is the type of file you're going to iterate over, and Camel knows it's a CSV because it detects it's a CSV, so it's going to start iterating over the rows. Then it's true. Line 9, I did a trick, which is I'm going to process and say process CSV, and I separated that process into a separated file. But bear with me, I'm just doing this in which the process CSV, what it's doing is preparing the maybe tweaking the CSV. If you don't need to tweak the CSV to call the XML API, if you need to change attributes, if you need to change anything, what it's going to do is just send to the API the same row you are using right now, and just send that value to the API. If you need to add header something, well, yes, you need to configure that, unless there is a specific component for this endpoint API. Then the response of this API is an XML. So I'm going to unmarshal, tell it it's an XML, and process it. Again, this process is because I'm going to show you how to do transformations of data, but it can be done in different way. If you're using JSON, you can also do like on the following line, in which I'm preparing the SQL. And you see this exchange property? What I'm saying is I'm going to use this property that comes from the previous step that I prepare in the process XML. But if I just wanted to call and use from the response of the XML one of the attributes, I can use here an XSLT type of XPath, and I don't need to do any process in between. I can just call the attribute on the XML, and Camel knows it's an XML and where to find that attribute in the XPath, and just fill it on the select to the database. And then I say, send it to this database. And of course, this bin, I simplified this, and this Postgres bin, it will be in some properties file. But what does it contain? It contains just what is the IP and the port and the username and password. So it's not inside the code. And then again, I add another process because maybe you want to process something, or maybe you just need the result from the database, depending of if you need to tweak it or not. You can do all these processes. I put process to show that you can call something externally, but seriously, you can also just use XPath and JSON path to tweak it a bit inside Camel. And then I say I'm going to aggregate all these threads of messages that I'm getting. And I say, well, this aggregation strategy is just count to 5, and every 5 messages just send me. But there's many other aggregation strategies. So you can use any other aggregation strategy. And then at the end, I process build your JSON, because on this example, I was showing geospatial data, and I wanted to add some specific headers to the JSON, so it's geospatial data. And finally, I store it in a MongoDB. And you can see that, again, I use a bin in the Java side. This is Java. No, this is... yes, this is a piece of Java, but this piece of DSL, you can also use it in JavaScript. And this bin is another properties file that contains, again, what is the MongoDB, what is the user, what is the password. But if you don't want to have it in a separated properties file, which you should, you can also put in the code. So I just described the full workflow in just less than 30 lines of code and a lot of comments. And if you ever need to change something, for example, now I'm not going to call an XML, I'm going to call a JSON API. Well, just change the URL, and on the unmarshal, don't say Jackson XML. Just say this is JSON. And the rest will work. Camel will understand, oh, this is a JSON. So the property I have to extract from the previous step It's not an X path, it's a JSON path. Oh, it's here, done. If for some reason the source CSV is somewhere else, you just have to change that line and say, instead of using the HTTP component, instead of using the S3 component, now I want you to use, I don't know, some Google Cloud Storage service. And it works. And this is the beauty. You tell very high level abstractions to Camel, and Camel translate that to implementations. If for some reason Postgres or Mongo changes the API and now you have to call them differently, that's fine, that's perfectly fine. You know why? Because you just update Camel, and Camel will have the updated version on how to interact with this protocol. And I mentioned before, you have also the version for Cloud Native, which is the camel-k. And this works, it's Kubernetes native, so it works with YAML mostly. And the idea is that we simplify even more this DSL I have shown. It adds some overhead at the beginning, because what you are doing is posting a custom resource definition of Kubernetes. But then you can see that, for example, this is an example on how to build a Telegram bot with Apache Camel. And this Telegram bot, the only thing you need to do is add the token. And Camel knows how to interact with that with Telegram. You add the token, and if Telegram changes the API and what it does, you just update Camel, and it will have the latest version to interact with Telegram. And the idea of Camelets is to have to simplify integrations. So the concept is that you grab data from somewhere and push data from, have a source and a sink, which is a very native concept. You grab data from somewhere, you push data somewhere. And you can have intermediate steps for the ETL, and you can have, it's the same functionality you have in Camel DSL, but simplified. We remove a lot of because sometimes the components in Camel have dozens of properties, configuration properties that most users don't care about. So just Camelot simplify it. And if you're worrying that maybe it's difficult to start with Camel because you need to learn the DSL, well, spoiler, you will have to learn it with any other integration framework you try. But if you're wondering if there is some low-code, no-code integration development tool, well, yes, there is. I want to show you this, which is Kauto. This is a project we have been working on for the past year, and the idea is to have, you can have a low code or no code. And well, here on the right hand side, there is, it's connected to a Kubernetes, and it's going to show you how it deploys. But as you can see, what I'm doing here is just drag and drop, and I get a form with different configurations, and it's building the integration code. I don't have to write any line of code to do this. This is a simple timer log. So every, I don't know how many seconds I put there, it's going to drop a log drop a line in the log. And well, I just click play, and it will create the proper custom resource definitions in the cloud. So the Camelot building in this case, which is a type of camel root, will be deployed. And it's pretty fast. Now, if I check the logs, it's going to show the lines of the log lines. So I like this approach because, yes, here you're seeing the code because I wanted to show it. You can hide it, the code, and work only on the graphical space. And it generates a valid code, of course, but also it guides new users into how to create a new integrations. And also it has the catalog of all available steps, which is nice to have because not everybody knows all the potential connectors or transformations or steps you can add to an integration. And also it allows you to see how the source code is being generated on the fly, which can help you learn this language and will help you learn it. The learning curve will be easier for you. And on the following, this other video is the low code version. So you start writing things, but you don't know all the required nitpicky details. So you just write what you think or you need, and then Kauto will autocomplete the things that are missing and generate the graphical side. And now you want to do some drag and drop. Why not? Well, you can still do it, the drag and drop. And the source code will get updated with what you just drag and drop. And then you remember something that you know already how to write it, then you write it. So you can combine the low code and no code easily and generate this way all the integrations you need, and also you can deploy easily as I showed you before. It's just another way of getting introduced to this world in a less painful way. Although Camel DSLs should be easy to learn and understand, as you have seen in the code. It's you can even read it directly without knowing exactly this is Camel, and it's very easy to use. And if you have any questions, you can find me as Delaware on many platforms, on LinkedIn, on Twitter, and well, I'm here for any questions you may have.